classifying stars on the Hertzsprung-Russell diagram. Today, I can classify stars based on brightness, color, and temperature. Our Sun is a medium-sized main sequence star. It's located in the spiral arm of the Milky Way galaxy. The Sun is many thousands of times closer to Earth than any other star.
It rises in the morning, giving light to the land below it. It sets in the evening, leaving the world in darkness. It even provides the heat and energy necessary for life to survive on Earth. You know what I'm talking about. The sun. Because it is so important to us, the sun has been studied and observed since ancient times. Astronomers today still study it and are constantly learning new things about the sun, the center of the solar system. The sun is a star, not so different from the stars that can be seen in the night sky. It may look different, but that is because the sun is many times closer to us than any other star, which allows us to see how hot and bright it is. The sun may be close to us compared to other stars, but it is still very far from the Earth, about 93 million miles or 150 million kilometers away. Although the sun is so far away, it only takes sunlight about 8 minutes to reach the Earth because light travels so fast. Because the sun is so far away, however, it seems much smaller than it really is, more than 100 times the width of the Earth. The sun is so large that if it were empty, more than 1 million Earths could fit inside. The sun is the largest object in the solar system. In fact, if you collected everything in the solar system, including the sun, the planets and dwarf planets, comets, asteroids, and moons, the sun would account for more than 99% of it, with everything else adding up to less than 1% of the solar system. As far as stars go, however, the sun is average or even small in size. It is called a yellow dwarf, and there are billions of stars like it in the Milky Way. Like other stars, the sun is made of gases, mostly hydrogen, with a little helium, and only traces of other elements. These gases are held together by the sun's gravity, which creates such intense heat and pressure that it causes nuclear fusion, a process in which hydrogen atoms fuse to create helium at its core. The sun's core is about 27 million degrees Fahrenheit or 15 million degrees Celsius. By the time heat from the sun's core reaches its surface, temperatures have dropped considerably. The surface of the sun is only about 10,000 degrees Fahrenheit or 5,500 degrees Celsius. Unlike the Earth, the sun does not have a solid surface. You may be surprised to learn that the sun's gassy surface is not calm and quiet. Instead, the sun is constantly moving and changing, with sunspots, or dark patches of cooler temperatures, and solar flares, or eruptions of high energy radiation, frequently marking its surface. All of the planets in the solar system, including the Earth, orbit around the sun. In turn, the solar system orbits around the center of the galaxy in which we live, the Milky Way. It only takes the Earth 1 year to complete an orbit around the sun, but scientists estimate that it will take the sun about 230 million years to complete an orbit of the galaxy. Since ancient times, humans have understood how important the sun is for life on Earth. Without the energy provided by the sun's radiation, the Earth would be dark, cold, and uninhabitable. Although it has been studied for thousands of years, there is still much to learn about the sun. I hope you enjoyed learning about the sun, the center of our solar system.
Our sun is a medium-sized main sequence star. If we locate the sun here, our sun belongs to the main sequence group of stars, which is a diagonal band that runs from very bright hot stars to very dim cool stars. Our sun is pretty much in the middle, so we say it has a luminosity of 1. The sun is located in the spiral arm of the Milky Way galaxy. We'll locate the sun. This is a top view of the Milky Way galaxy. Below here would be a side view of the Milky Way galaxy. And of course, we can't see the Milky Way galaxy like this because we're in the Milky Way galaxy. The sun is many thousands of times closer to Earth than any other star. So here's our sun, a star, Mercury, Venus, Earth. So the sun is the closest star to Earth. Star classification. Let's take some notes. Stars can be classified in 3 ways: by their size, how massive the star is. We can see Betelgeuse is a very massive star, it's very big. Temperature. A star's color reveals its temperature. Red stars have cooler temperatures, and blue and white stars have warmer temperatures. So on the x-axis here on the HR diagram, you can see temperature increases from right to left. So again, your cooler stars are here as your warmer stars are to the left. Brightness magnitude. The amount of light a star gives off depends on its size and temperature. Okay, and again, the sun has a solar luminosity of about a 1, and we base all other stars off of our sun. HR diagram classifies stars' temperature and brightness. Groups of stars are supergiants, giants, main sequence, and white dwarfs. Use the HR diagram to describe and classify the stars. Complete the true or false statements. Deneb is a giant star. So here's Deneb. Does it fall under the giant group? That's false because it falls underneath the supergiants. Barnard star and Vega are main sequence stars. So here's Barnard star and here's Vega. They are grouped as the main sequence stars. That's true. Polaris is brighter than the sun. So if the sun is here, I see Polaris above the sun. Yes, Polaris is brighter than the sun because brightness increases from bottom to top. So your brightest stars are at the top of the HR diagram while your dim stars are at the bottom. White dwarfs are dim stars. So here are your white dwarfs. And yes, they are dim stars because on the brightness scale, they are located at the bottom. Betelgeuse is hotter than Spica. So here's Betelgeuse, and let's find Spica. Betelgeuse is cooler than Spica. Spica is hot. Spica is a blue star, and its temperature is greater than Betelgeuse. Betelgeuse is a red star, which has a cooler temperature because, again, temperature increases from right to left. Regal is about the same temperature as Series B. Let's find that. Regal is the same temperature as Series B. Here's Series B, and let's find Regal. Okay, Series, oh, that's Series, but we need Series B. Up here it is down here. So Sirius B and Regal, yes, they're on the same temperature scale because our temperature again increases from right to left. So they are the same temperature, but notice that difference in brightness. Sirius B is dim while Regal is bright because of brightness at the top. The sun is a medium in size and brightness. Yes, the sun is in the middle. It's a yellow medium star. Warmer stars are red. Incorrect. That's false. Okay. Red stars are cool stars, where blue stars are warmer stars. Okay, so your true and false. Today's assignment will be a true and false in Schoology. So, for our connection question today, it's a star test question. It says, which star belongs to spectral class M and have high luminosity? So, spectral class here is on the x axis. Spectral class M runs vertically up and down. So, if I'm looking for the highest luminosity, that would be these stars in this quadrant here. So, that would be grouped as a supergiant. If I wanted to know what in spectral class M, which stars have the lowest luminosity, that would be down here, part of the main sequence. Now, your main sequence, that's where the majority of the stars are, and it goes from very hot, bright stars to very dim, cool stars. And our exit today is to describe Barnard's star's brightness, temperature, and color. So Barnard's star is here, and we can say it has a temperature less than 3,800. So it's a cool star. Its color is red, and it's also dim because on the brightness scale, it's located at the bottom. So to summarize, Barnard's star is less bright than our sun, temperature below 3,800 kelvins, and is red. I hope you enjoyed learning about stars.